Hey, welcome to my talk, JavaScript's secret life between the tasks, between the ticks. So yeah, it's true. I always passionate about telling people the things that I'm really passionate about. So this is one of the topics that I'm really passionate about. So here it is. So my question is, has this happened to you that in your life as a developer, you came across a JavaScript code, even in an interview, that what? Does it work literally like that? Like React, when we talked about asynchronous operations, how do they work? How does use effect work? How does use layout effect work? What are the features of JavaScript that it uses? Or even Angular. We have constructor, we have ng on init, we have some change detection logic in Zone.js for Angular. So all of these things, even in JavaScript, set timeout, promises, and these stuffs, some interview questions, all of these things are the topics that from time to time we blame JavaScript. Yeah, it's JavaScript faults. Yeah, my code's supposed to work fine. To be honest, no. Most of the time, it's about our basic knowledge of JavaScript. And this is what my talk is about. It's about the basics because I believe in foundation of languages. In this case, JavaScript, instead of learning frameworks and others. Yeah, they have pros and cons, but to be honest, frameworks introduce new features, new APIs. But the thing that doesn't change, it's JavaScript foundation and logic. So let's dig deeper into this. My name is Mohamad. Everybody calls me Mo. My friend tried to pronounce my last name. No worries, no worries. Everybody calls me Mo. I'm passionate code wizard at ING Bank. I have 15 years of experience as a developer and tech lead across 4 different countries. As a personal note, I have 2 kids. I love to play with them, and also I love playing video games. To be honest, these days, yeah, I'm playing Resident Evil Village. Is there is a fan? Ping me. So yeah, I'm here because I'm starving for sharing knowledge with the community. Also, there is a QR to my page. We can connect on LinkedIn and other social medias. I love to connect with people. Please feel free to scan it or reach me on LinkedIn or other social media. So what's the plan? The plan first, basics. Then handling tasks, how JavaScript handle tasks, asynchronous or synchronous. Then we go to event loop, dig deeper into that. And then we learn by practice. So this is the time that, you guys at home, behind your desk, on your phone, you can think about my question and answer it to yourself and, learn by practicing and I actually, question and answers. Then we are going to have a demo and then some bonus tips. Let's start with the basics. The only basic that I need from you guys is just one thing, which is the blank in this case. JavaScript is single-threaded. This is the only basic that I need for this talk. So keep in mind always that JavaScript is a single-threaded. We don't have multiple thread in JavaScripts. In another way we have, I'm going to tell you some details, but generally, it's single-threaded. Let's go to handling tasks. Synchronous versus asynchronous. There are some tasks in JavaScript that I call them long tasks. What does it mean? It means that it's going to long forever. Like this while loop. While true, console log hey. What does it log? Of course, it log hey, and it doesn't end. Why? Because JavaScript, as we talked about, is one thread. So there is one thread that handling everything behind the scenes. So if that thread is busy, so it means that no other codes would be run behind the scene. And it is synchronous. Since that it is synchronous, it means that it goes line by line. So since the main thread is busy doing this infinite loop, it's not going to end. But some tasks are long waiting tasks. For instance, set timeout. As you know, set timeout, yeah, it's going to wait for an interval and it's going to run a function for us. Or fetch, sending a request to an endpoint to fetch some data. or in some cases using a service like GPS services in our browser through navigator.geolocation.get current position. All of these functions, I call them line waiting tasks. So it means that you should wait for something, sometimes time, sometimes a cloud service, an endpoint, and sometimes your device, which is in the last example, it's GPS. So these things happen in an asynchronous way. So it means that whenever that function satisfied, for instance, in this case, set timeout 1 second passed, so it's gonna run my function. So everything happened in an asynchronous way. They are not sequential. It's gonna happen later on based on the satisfying the function. So since we just learned what is async, what is sync, and single-threaded JavaScript, it's time to see how does event loop works in JavaScript. There is a code snippet that I want you guys to have in mind. I have two functions, foo, bar. The first one, foo, it just returns something. So simple. Bar function initiate a set timeout with 1000 milliseconds. On line 11 and 12, I'm calling these functions. So foo and bar, line 11 and 12. So easy, right? So let's see how does JavaScript run this function when it goes to call stack. So as you know, we have call stack, right? Call stack is responsible for putting our functions in a queue, and actually it's a stack. So last in, first out, right? So as soon as I reach line 11, foo would be on top of call stack. So what does foo function do? It just returns something, fine. And it doesn't initiate any other functions here. So again, fine. So let's move on. And then foo gets out of the call stack because we just ran it. And we go to line 12 for bar. But for bar, it's a little bit different because on line 6, we are trying to initiate a set timeout. So set timeout comes on top of that. This is the time that some magic comes in play, which is web APIs. Web APIs for set timeout is something like a timer service, something that you can send a task to that and it's going to wait for 1000 milliseconds in this case. So we register in our web API timer service a callback. Please wait for 1000 milliseconds and then run this function. So how does this function goes to call stack again to be run? The thing is, call stack would be empty, right? Because our running is done. There is nothing else after line 6 to run and also after line 12. But the callback function in timer service is supposed to be run. The tricky part here is that callback function goes to a specific queue. There are some queues in JavaScript. In this case, our set timeout callback goes to this queue. As you know, queues are first in, first out. So this one is at the beginning of my queue, so it should be served. This is the time that event loop grab this item, this callback, and put it in the call stack. So yeah, something again is in the call stack, right? So it means that JavaScript just followed the normal procedure that it's gonna done. So it tries to run the function. If this function tries to run some kind of services, it's gonna end up in web API again in the queues, right? And this is very important that I want everybody to listen to this one. Call stack is empty, web API is empty, queue is empty. But the point is about call stack. As soon as call stack is empty and not JavaScript doesn't have anything to run, it means that my main thread could be free. A browser render happen. A browser render happen when the call stack is empty. So let's move on. Let me recap everything. Imagine in call stack, you have a set timeout or fetch. Set timeout supposed to go to timer service. Fetch supposed to go to network service in web API. So web API, as soon as these functions, satisfied, so they go to corresponding queues, set timeout callback, and fetch callback. Again, they go to call stack, the callback functions I meant. So they're gonna run normally. So this is the recap of event loop in a simple way. Let's make it a little bit more advanced. Imagine I want to append an element to the body, right? So somewhere here I've created my element. I run document.body.append child an element. So it's gonna append my child. So I know that by default, all elements in DOM display is blocked. Right? It depends on the element, but just imagine that the display is visible. People can see it. So on line 3, I'm going to set the display to none. But, guys, maybe my user see my element for 1 millisecond between line 1 and 3. Yeah, it might happen. So, yeah, I know what to do. So let's swap the lines. First, set the element display to none, then append it. You're going to say to yourself, yes, I did it. But to be honest, no, that's not the thing. Do you remember 2 points that are going to help us in this case to answer this question? The first one is, JavaScript is single-threaded. When call stack is full, it means that it is trying to run something. For instance, between line 1 and 3, our call stack is full with this function to run. So our call stack is not empty. So it means that between line 1 and 3, we are not going to have a browser render. Browser render, when does it happen? As soon as call stack is empty. So in this case, call stack is not empty, so no. Both these codes, the one on top and bottom, are the same. Even if you want to, flash an element, I want to flash this element, the element that I just appended to the body, set display to non-block, non-block, non-block. So do you think that my user is gonna see? No, because from line 1 to 14 in this case, my call stack is empty, so I'm not gonna get any browser render. So browser render won't happen, no render. So it means that as soon as I set the element style display to block, my element, as soon as I pass this line, I'm gonna just make the element visible. So there is no none set for this property. I'm just, waste my time on this one. So as soon as I pass line 14, browser render happen and my element would be visible, no flashing. So we just learned, I guess, some stuff, and we can, learn some tips and tricks by questioning and answering. Let me start with the simplest question ever. What does this like? Let me have something. Yeah, what does it like? Yeah, of course. Both answers are correct. A and B. Here. Yeah. It's gonna just like here. So let's move it to the next step. I just added a set timeout to this code statement. Set timeout first, console like here, then set timeout without any duration, which is the second parameter. By default, it's 0. So which one goes first? Here timeout or timeout here? This is very important. You can answer it right now based on your knowledge. Just imagine what does JavaScript do? It is synchronous from the beginning. It goes to line 1, log, console log here. Okay, and then go to line 3, register my set timeout. My set timeout has been, the timer has been installed in the web API. Web API wait for 0 millisecond, which is in reality, to be honest, because of the CPU overhead and the stuff, it's around 4 milliseconds. And then it goes to the queue, then it goes to the call stack and run the function. We are going to get console log timeout. So the answer would be here timeout. But if I change set timeout and console log here, like this, does it change anything? I just swapped the lines. First, set timeout, first registering the set timer, and then on line 5, doing a console log here. Does it change our answer? To be honest, no. Because all the things that's supposed to happen and even waiting for 4 milliseconds, since, everything, putting this callback into the call stack, it's going to happen after line 5. Yeah, by the end of the day, you're going to get here first, then timeout. Right? And also, guys, I'm going to put some, dotted lines in the responses. These are the places that rendering happen, right? So after line 5, we are going to get a render and then the timeout log. So let's add another thing, a promise. Promise.resolve.then. Promise.resolve is a function in, async await world in JavaScript that resolve immediately. So it means that, yeah, it is a promise, but has been resolved immediately. It's like somehow set timeout 0. So where does promise come? Does it come after? Promise comes after here or after timeout? So, somehow I want to understand which one comes first. Which one goes to the call stack sooner? To be honest, in order to answer to this one, which the answer is B, you should know one tip. The tip is priority of promises are higher than timeouts. They have their own name, so we're going to get to that. But since the priority is higher, so promise comes first. So just imagine what does happen. Yeah, first here, of course, because it's going to happen synchronously, line 5 runs, and then it register one promise, register one timer. Both goes to the queues, corresponding queues. But it's time for even loop to pick one of them. It's going to pick promise because the priority is higher. So yeah, let's make it a little bit more advanced by instead of using promise.resolve, I'm going to use new promise resolve. New promise constructor. New promise constructor, what does it do? New promise constructor accept a function that is the logic of my promise in this case. When does body log happen? As you know, our answer from previous doesn't change. Here, promise timeout. Here, promise timeout. But where does body come? The body log would happen right after here. Why it's happening? Because new promise constructor is exactly like this. It runs the callback function immediately. So it means that here and body are going to run in one cycle of event loop. Yeah, here, body, and then render happen. Then it's going to pick the promise, then timeout because of the priority, as you know. Just keep in mind that when you put something in the constructor of promise, it's not going to happen in a separated thread or something, and it's not doing something parallel. And sometimes maybe you mix them together. In this case, I have two set timeouts, timeout 1 and timeout 2. But in the first timeout, I am creating a new promise as well. Based on the tip that we learned a couple of minutes ago, promise priority is higher. So it means that the answer would be timeout 1, promise, timeout 2. Why? Because as soon as we run timeout 1 and we register our promise, event loop wants to decide whether run set timeout callback or this then callback. Which one has a higher priority? Promise, right? So I want to show you some ways to understand, this logic more by blocking our single thread. Just imagine that I have a function loop inside the loop function, I'm gonna loop function again using a promise. If you use a promise, the answer might be two things. A, yeah, all of them at the same time, but B, after each log, you're gonna get a render. Actually, the answer is A, because you won't get any render with promises. You can do the same with set timeout. In this case, the answer would be B, because you're gonna get one render after each timeout callback. And we have another function, request animation frame. Request animation frame is somehow like set timeout. It's gonna get renders, but in a different way. I'm gonna tell you why. So if I want to show you everything in an animation for task, so we're gonna pick one task to run. If you add an additional one inside running that item, actually, JavaScript is gonna skip that. So it's not gonna run it and even picking other items from tasks, which is set timeout. Set timeout and all timers are tasks, so it's gonna pick one by one. But for request animation frame, it's gonna pick all the items, but not newly added ones. So it's gonna skip the newly added ones. So for the task, our page would be responsive in an infinite loop, but in an animation callbacks, it's gonna be responsive as well. But what about microtask, which is promises? For promises, it's gonna pick tasks, running the tasks, and also pick the additional items and running them. So it means that for microtask, if you have an infinite loop, it's not gonna make your page responsive. So if I want to recap everything, so call stack, web API, we have three different queues. We have microtask queue, which has the highest priority. We have task queue, for instance, timers or task queue has a little bit lower priority than microtasks, but we have a request animation frame. Actually, request animation frame priority is not like microtask and task. So it's gonna happen whenever browser requests a render. Whenever browser wants to render something, it's gonna run a request animation frame. So the picking logic is, microtask try to empty out. Task queue, it picks one by one. For request animation frame, it's gonna empty out, but not new ones. Yeah, you might ask, we are single-threaded, but can we have something in parallel in JavaScript? Yeah, of course, we can have it using worker threads and web workers. Let me show you a quick demo, super fast. So as you see, I have a CSS animation in the middle, and I'm moving something with task, moving something with request animation frame and microtask. If I click on the task, everything works fine. My browser is responsive. With request animation frame, still responsive because you can see CSS animations. But if I run these two and click on microtask, everything would be freezed. Why? Because microtask tries to empty out the queue and it's an infinite loop. It's not gonna work for us. So that one is not responsive. And also, let me show you something else. As you see, task and request animation frame, they are infinite loop, but task is a little bit faster in this case that comparison to request animation frame. The reason for that is your FPS, your refresh rate of your monitor. My refresh rate at the moment is 120, so it means that for request animation frame, it's gonna happen 120 times per second. But as I mentioned, the set timeout 0, it's a little bit around 4 milliseconds. So it means that 1000 divided by 4, it's around 250 times per second. So that's why the task is a little bit faster. And also, if you go to Performance tab, and if I record something, click on task, stop it, you can see everything here as well. As you see, here is my loop function, here is my set timeout, and here is installing my timer. See, you can check everything in performance tab as well. As you see, my set timeout registration, there is a link between them, and it goes to my function call, which was the loop function. So let's move on. Yeah, some bonus tips and we are done. There is a function in JavaScript, instead of using promise.resolve.then on line 5, you can use queue_microtask. Queue_microtask, yeah, it's just gonna make your life easier instead of doing promise.resolve. If you want to a function happen in the next cycle of event loop. We have nanotask in Node.js as well. So nanotask, we call, nanotask is the function is process.nextTick. Process.nextTick in Node.js, it has the highest priority. As you see, I did a queue_microtask and also process.nextTick, but nextTick was on top because it has the highest priority, and we call them nanotasks. We have request idle callback if you want to run something when your browser is idle. Yeah, call stack is empty, everything has been done, and you want to do something in the background for your website, you can use request idle callback. And also there is a new API in the browsers, scheduler that posts task. It accepts a function and a priority, 3 different priorities: user blocking, user visible, and background. I guess now you have an understanding of what are the differences between user blocking, user visible, and background. So you can scheduler, and yeah, the coverage is good enough, 75%. It's been there for a while. And I guess right now you have a better understanding of some life cycle events in your favorite framework. Use effect, use layout effect, some interview questions, or life cycle in Lit HTML, life cycle in Angular, or other frameworks. And here are the resources. I highly recommend the first two, Jake Archibald on web browser event loop and a scheduling task, HTTP 3.203. And also I did a talk about the use effect and event loop in React Advanced Conference last year. You can give it a watch as well. Thank you. I hope you enjoyed it.
Hey, thanks again, Mo. Again, I really value when people do things that are vanilla.js, where they explain the core basics, because it's nice to use frameworks, but at the same time, it's also very important to know what's underneath, so that way you really know what you do. And again, being a nice like React or Vue or Svelte or Angular developer is good, but being a good JavaScript is better, in my opinion. So yeah, I
That's the foundation, right?
Indeed. Maybe a hard topic is, how do you work with error handling in async code? Because that in JavaScript can be a bit tricky. Do you have any good tips or advices or tools or anything?
I guess everybody is familiar with the term the callback hell, right? Because
yeah, definitely.
the syntactic sugar that async and await keyword brought for us, it's it's very good, to be honest. Because handling tasks with .then, .finally, .catch, and these stuff are it's a nightmare. So in order to prevent getting into callback hell, I highly recommend everybody to use async and await keywords and async functions generally, because whenever you use async await syntax in this way you can easily use try catch functions, the native JavaScript error handling, and you can easily handle all your errors.
Yeah, I thought that you were about to say, yeah, just use Sentry to catch the errors and then fix them quickly. Yeah. Do you have any common pitfalls that devs usually fall into when it comes down to async programming? I mean, yeah, probably a lot. Let's maybe pick one obvious or the biggest one.
The points that I mentioned, briefly about the performance tab, I highly recommend everybody to have an eye on performance tab. Yeah. Because sometimes you write a piece of code that you think that it's gonna work normal, but from your eyes it seems normal, but in performance tab it's totally different. So yeah, whenever feel like a part of your code becoming heavy, there are some functions in JavaScript performance, I meant measuring from developer tools that you can put in your code and measure it in your developer tools and see the report. I highly recommend everybody to take a look at the performance tab because I believe nobody uses it that much. It's a tab that we rarely go to that. But to be honest, it's more than that. And also, if you want to debug your application in Performance tab, keep in mind that open your website in guest mode or incognito mode, because most of the time we have a lot of extensions in our browser, and those added some JS to your
Yeah.
page and make a lot of noise.
I very much agree. I have quite a lot of extensions on my Chromium browser, and lastly, I struggled because my disabled extension didn't work, and it's because I have like 50 things running. So that's why now I just use a vanilla Chrome. There's nothing else, so that way it's very easy. Because also the network tab, that way it's not polluted by third parties. So that's indeed very important. And again, regressions and probably automated CI with Lighthouse or run metrics are very important too. I very much agree. Like, I think that we both worked in a bank, so now we're like conditioned with that. So that makes sense. Maybe another one. How do you optimize async operations for better performance?
Optimize ASIC. 90% of the time I do it through Performance tab.
Yeah.
Because if you take a look at the Performance tab, I didn't have time to dig deeper because you can see a lot of things. For instance, I'm putting two different things into the call stack, into the queues, and they're supposed to run later on. But one of them is setting a state that sequentially, it's gonna render something on my page, but the other one is just logging and initiating a network request behind the scene. So if you take a look at the Performance tab and you zoom in, you will see when does
but
rendering
that's
happen
also a
in
bit
Performance.
scary because that Performance tab is quite complex. You have a lot of things, but it's indeed a bit of a learning curve, but I recommend it too.
And also keep in mind that the recent features, as you know, Chrome recently introduced, Gemini Nano in Chrome on device,
for
and
debugging
also
AI.
Yeah, exactly. And also in developer tools, so you can go to Performance tab, and whatever block that you don't get it, just right click on it and press Ask AI.
Okay.
So it's gonna tell you what's going on, what is this block about. So most of the time you're gonna get confused, right? What is it? What does it do? Maybe we don't know. But with the AI and integrated into the developers tools, just right click and press Ask AI.
Simple, clear. Yeah, thanks.
Yeah.
Maybe as a last note, could you share your slides in the chat?
Yeah, of course.
I think you're gonna have them on Twitter or something anyway. But
Yeah, I'm gonna share it here as well.
Anyway, thanks a lot for the talk, Mo, and see you at the next Amsterdam meetup or online.
Yeah, for
Have a
sure,
nice
for sure.
evening.
And also, at the last note,
Yes.
because as you noticed during my presentation, I was using some GIFs.
Yeah.
I don't know that you have already, watched this series, Ted Lasso series. I highly recommend everybody to watch that because believe me, each episode of this series, it's like a therapy for you. So go for
that's
it.
also well, I was more busy on the Severance one, so like more
Okay.
Doomsday, which is the opposite. But like if it's a good vibes one, I heard a lot of good things from it. So people, that's like the tip of the day. Just go watch Ted Lasso as a
Give it a
recommendation
watch.
from Mo.
It shouldn't be always technical, right?
Yeah. All right. Perfect. Thanks a lot, Mo. Have a nice day and see you soon.
Thank you.